So this is kind of what we talked about last week, but we have more in depth on the AMD document, and we had some conversation here around kind of how it works and things like that. And we talked about Guohan had a few questions here, and I think I put these in the last meeting notes. And so this next session, we were going to pick up with AMD, and then if Guohan joins, maybe go into these topics here. So I'll stop sharing my screen and let you guys pick up. Oh, Balky's joining. Okay, cool. So AMD team, did you want to go ahead and pick up where we left off?
Yeah, I'm trying to share this.
Okay, sorry. And that was my dog making noise. Sorry about that.
Okay, everyone able to see what I'm sharing?
I can.
We can start. I think we had stopped.
Page 10.
Yeah, I think somewhere here we just finished the state machine is where we had stopped, I think.
Mm-hmm.
So next, I think we can continue on from here. I think here, I think what's coming is we have some side definitions with given the background of the state machine we were talking about. So there are two aspects of messaging that's going on for control. One is there is some messaging that is going on between the state machine itself, talking back to the SDK. So this is the SAI SDK definitions that we have below. And then there is another aspect of communication that is going on, which is the communication happening between the boxes. So there is some communication happening within the node, which is the SAI SDKs, the SAI SDK definition messages. And then there is a messaging that's happening across the nodes, which is the control plane, over the control plane channel. And those are defined later on. I think we'll come to that section later on, which is the gRPC definitions. Right? So first to touch upon the SAI SDK, so which is this in-node communications. I'll just start from the end here. And then we can look at what are the different functions that we have, and the attributes are defined on top. Right? Again, one disclaimer, not the still picking up on SAI and this thing. So if there's potentially are mistakes here, which feedback is much appreciated. So one is the registered.
These definitions come from the OCP or the Linux Foundation or the SAI repo, or just little or are we're making these, we're creating these?
This is made up. This is created. This is made up. Awesome. This is something we are creating for now. Yes.
Okay.
These are essentially new definitions that we are saying we would want. So one is, I think there is, if you look, when we looked at the picture, right? So there was this, there is this channel that we were talking about between the DPU. These were messages that we are passing through to the, if you remember, we were talking about a stream. So there is that channel that we have to establish. The first message here, the first call here is to register that CP channel function. So in this document, I'm just suggesting we use something like a named FIFO kind of a thing, so that it can be to simulate a stream. if there are other ideas that the community has on what is a better way to represent a stream in SAI, that please do suggest, right? But essentially, this is to create a stream, a bidirectional stream between the SDK and Sonic, right? So that I'm representing here. There's a register CP channel, but if you look at the actual definition of the function and the attributes in the function, it takes a named pipe, right? And it's a named FIFO which is being used for channel. Then there is the get capabilities function. So this is for in the state machine. We had this where there was a capability exchange, but for the capability exchange, before the exchange happens with the node, there is a capability get from the local hardware implementation, from the local DPU implementation. So that is this get capabilities function, right? And then there is, maybe I can just quickly go to. I'm sorry, I'm not sure how to exactly handle the code thing, but I'll try to sequence out this thing. And you can, I think it's open. Any comments on the from a review of this thing also is most welcome.
Sanjay, just a quick question on just the SAI API, right?
Sure. Yeah.
So, as you know, for Dash overlay APIs, as a rule, we basically said we are going to derive these SAI APIs through a P4 model, right? So we also basically said that, okay, that P4 model is going to be the source of truth from we are going to auto-generate these APIs. Now, for the underlay APIs, prior to these overlay APIs that we had in the OCP SAI, generally we have what we call it, some Visio diagram, really going through some logical pipeline, and that becomes a source of truth from where we are going to derive the API, right?
Mm-hmm.
So with this discussion that we are having right now, are we just basically, just brainstorming here, and then eventually we are going to have some sort of a model, whether it's a Visio based or P4 model based, so that we can sort of like, officially have some representation saying that, okay, this is how it's going to be, depicting it?
Yeah, so that's a good question, actually. I don't know the correct answer. One thing that I know is representing this as a P4 model might be a little challenging, is my opinion, right? Maybe so that I can think maybe I'll get this thing on that Visio model and see if that is a better way to formalize it and represent it. Right, maybe that is a better way. Yeah, because this, it's not a P4 behavioral thing. Truly, right? Some of these get capabilities, all these are not truly a P4 thing. So maybe we can do it. We can explore looking at how to formalize it.
You can probably see some examples in the OCP SAI GitHub repository, and that'll give you some sort of like a examples of how you can show this thing. But all in all, I guess the way SAI actually represent anything is SAI is just a logical pipeline, right? So however you represent it, it's just to basically show that, okay, we need to get something done, and then eventually something should be represented. Eventually, what has happened is that even in the underlay APIs, as a pins project has really represented even the SAI through SAI.p4 underlay in the P4 as well. So those are good examples to see how, even though what you may think that, okay, this may not be able to be representable in P4, you may find some ways to represent it in the P4 also. But anyways, I think, just take a look at it, and one of those two ways, I think we should explore.
Okay, cool. Yeah. So I think for documentation, I think we can do that. Yeah, I think maybe now we look through. I think my purpose here was to put the messaging here so that we can actually visualize better or understand better. When we were talking about in the state machine, we were talking about we do this handshake with the DPU. This is what we are going to send across to the node, etc. I thought putting a little bit of structure to it so that it's more easily understandable. Right? Everyone reading it can get a mental model of what's actually happening behind the thing. So I think it's not probably the best way to document. I think next step we can see how to formalize it and document this thing, like you said.
Okay, thanks, Sanjay.
So this was the register CP channel attribute we're mentioning. All I wanted to show in this peer capabilities is so these capabilities themselves are kind of there are two sets of capabilities that we have talked about. There is a sonic implicit capabilities, and there are some capabilities which are very implicit to the DPU itself. So those will be probably something like something that can be very customized to the DPU at hand. So the message also tries to kind of keep it to this thing. Right? So there's some amount of opaqueness to that, so that it can be extensible, right, to handle different DPUs. Right. Then I think there is the so the attributes are defined here, right? There is some which are this thing, and then there is one which is a SAI list, which is actually an opaque this thing that comes through.
Are we going to offload the heartbeat through SAI?
So that is one approach. I think from the last thing, we thought we will have another discussion, Marian. But we are thinking the DPU right now, I think in this design, because we were thinking it can be pretty aggressive and happening thing. So we thought we can offload it to the DPU itself to do the heartbeat. So that way it can react faster also when there are switchovers, etc. But that is, I think, in the last meeting, we thought you should probably have another follow-up discussion focused on the heartbeat to see where we want to do it. We want to leave it in the sonic stack or offload it to the DPU. Here, I think I'm considering that.
From SAI standpoint, Sanjay, for the heartbeat, we will still need some means to configure the value of the heartbeat frequency, right?
Correct. That would be the northbound. I think the user might need to give input too.
Yes, sure. But do we need to have a SAI attribute for that to be able to program it if it's being done in the DPU, the frequency?
So this is what exactly, Rashma. This is what I was thinking. Yeah. Yeah. This had the interval and the miscount. This is the configuration that we're pushing to the DPU.
Sounds good. Thanks.
Then there's the process peer capabilities. So I think this one is the call that happens from once the sonic stack has exchanged the peer capability. So what's happening is each local node is using the get peer capabilities, get capabilities to get the local capabilities, and then exchanging it across. I think the exchange happens via the control plane message. We will see that in a minute. But so there is an exchange happening between the nodes. And once that happens, on exchange, each of the sonic stacks themselves, the sonic itself can actually do the first level of validation that they are compatible and they can actually peer up. Right. After that, there was also this component where the capabilities are hardware specific or specific to the DPU, the underlying implementation. So for that, this get process peer capabilities function, this is a SAI API that gives a chance to the underlying implementation to signal whether it is compatible or not, depending on what was each of the DPU capabilities were passed. Right? Then there is the DPU control message. So this was the message that we said last time. We said where DPU to DPU, there might be some control messages that need to be exchanged, which are relayed via sonic. So if it comes, so this is if the DPU to DPU control message comes via the control plane channel, this needs to be relayed back to the DPU, to the SDK. So this is the DPU control message, process DPU control.
Can you give
message.
an example of such a message?
So there might be, I think when we are doing the bulk sync, there might be a flow control message or to control the what records are being exchanged from DPU to DPU, right? For the bulk sync, right?
Yeah, but that would be a specific operation of inserting flows. No?
Right. Correct. So this is
Yeah,
something that.
So why do we put it under the umbrella of just process control message?
No. So for example, Marian, let's say we're doing the bulk sync. And I think the example that we were talking about in the last meeting is each of these DPUs may have specific ways which are more efficient for it to do the bulk sync. So for example, if there were multiple threads or multiple slices of flows that we have, it might make sense it is much more efficient to get flows from one thread, which is free to process flows, right? So there might be some message that the DPU can, but that the relay back to the other side, to the peer side, so that those are the flows, and there's some number of flows or a specific slice of flows that can be pushed across on the bulk sync channel, right? So this is a message that is going from DPU to DPU. So these are the kinds of messages that are.
So message is proprietary?
Yeah, could be proprietary if you want it.
Then what's the point of SAI here if SAI is just relaying the proprietary message?
We can say, I think there is a continuum, right? So there may be things that are common. I think that is something that we can, there might be common across multiple DPUs. We have the same set of requirements that we could make it in this control message. We could make it this thing. But there can be some things like the implementation itself, whether we have, I think one implementation may have this where we have different slices for performance for the flows, and we don't want to hold a lock while we are processing the other, right? Another implementation may not have the same this thing, or they may have a different set of requirements or restrictions or requirements or optimizations that they can implement. Right. If that is the case, now I think the question is, how do you achieve this when there is there are optimizations that can be specific to each implementation, right? Since you don't have the full set of.
I believe that if you think there are such cases, we shouldn't try to use SAI for that. Because initially, if I'm not mistaken, Guohan's proposal was to sync the already opened connections from active DPU to the one that is only coming up through the control plane channel, which would be universal. If there is, if you think there should be still some proprietary aspect to that, then it ruins the whole point of having a common way to synchronize the open connections between two DPUs.
Yeah, not really, Marian. So I think the connection itself, the flow sync message itself, we will see in the control plane in the following messages, right? The actual flows themselves are being synced. The flow sync messages during the bulk sync are being synced via the control plane channel completely. There is no proprietariness in that, right? So everything is, whatever is being synced is all defined exactly as it is this thing, right? Now, the only thing that is that will need to be this thing is what is DPU specific. If there is any optimization to be had, which we see some optimizations depending on the implementation from our experience, right? So there are some optimizations to be had by actually knowing what the implementation is. So if there are things like that, then you need some mechanism to be able to communicate those optimizations, or some mechanism to make use of those optimizations. And since these optimizations are cross node, it's not within the node, but it is within something that needs to be communicated across. This is that DPU control message. But the flow sync messages themselves, we will see what we are coming there. That is all in the open. Now, it could be that one might have one of the implementations does not need to pass any of the DPU control messages. That is fine. It still works, right?
So
does
in
not
that
depend on this.
case,
Does not
this
depend on these messages, is what I mean.
I see. So whatever is needed that can be generalized and common across different vendor hardware is specified in the non-highlighted portion. And the
Correct.
highlighted function here carries opaque information that is specific to however the DPU wants to process it.
Correct. If there is
Then we should rename it a little bit, saying it's an opaque information that's being
I
passed,
see.
optional as
Okay.
well.
Okay, we can do that. So I see. This makes it more like all DPU control messages, which might be misleading. I see the point.
Would you consider even those heartbeat messages to be the control messages?
No, that is not. That can be. I think that can be made common. I think it doesn't seem like there is nothing. It can. I think we can distill it out to have one common approach for the heartbeat. We can put up. I think we can specify the message format and make it into a common this thing too.
Or you can have something like basically even if you have control message, just you can have a control message function which can process all the control messages, and one of the messages could be say common message such as heartbeat, and there will be some bits in there which can say, okay, if somebody wants to define it as an extension, vendor extension or proprietary, they can do this thing. So I think instead of perhaps, I mean, that would be my like suggestion is that instead of actually doing this thing in the API level, API can basically have very clean interface, which is you are depicting right now, but you can choose to basically have some sort of like a control at the message format level, where you can have certain bits to say that okay, you can have these are vendor extensions or something like that.
I see. I got it. Yeah. Let me just. Yeah, so I think this, I think you can add additional things here. So right now, I think there is an attribute type and there's some attribute data. And the attribute type, I was thinking there'll be one opaque, whatever is this vendor specific information. I haven't added other things, but I see a point. There could be, I think in this thing, for example, if there is a heartbeat, the heartbeat could be here or something else, which is more, which we find is more common denominator across multiple implementations. Those could come in here too, right? And one of them would be the opaque thing or the vendor extension. The data would go in here and the attribute type for that would be this thing, I guess.
Yeah, that sounds fine.
Okay, I'll take a no. Okay, in that case, would it be okay to leave it as DPU control message? Ishma, you think that's fine? If we call it out in the attribute itself as
yes. If we can move the opaque information in the attribute, then this can, as long as it covers more,
more than just
more,
yeah. Right. Then similarly, there is this flow sync message that I think this is the actual flow sync message itself. So that was just the back channel. So the actual flow sync message is happening in the quote unquote open, if you want to say that, right? So it's in a well-defined format. So that is this. Then there is a upper role status. So this is this thing that we want to, any status, this thing that we want to do. And there is a CP control message if you want for between, it's not DPU to DPU, but from the Sonic stack to the underlying SAI implementation. Okay. Okay.
So what's the last one used for?
I'm sorry?
What's the last function is used for?
Just give me a second. Yeah, so I think this one is, for example, Marian here. Let me show the state machine and show what potentially where we could this thing. So there is this, there are some of these things where we are controlling to say to move from one state to the other, right? So we are saying start sync, right? So that one, for example, yeah, so that would be whatever is that operation that we are requesting it to do.
Yeah, but again, everything is opaque. I see type UN16T. Shouldn't we make it all standardized, like define an enum, start sync, and so on? Because
probably
you expect control plane to actually set this operation.
Correct, yeah. So I think that is my ignorance, Marian. I can look at this thing and see. I think the intent is to make it as a enum and specify this here. Maybe I think, like I said, my inexperience. I think this should be a enum,
so,
like you said.
Yeah, so I think I saw a comment from Guohan. He said that it would be good to have sample code that calls these APIs. I think that will make our lives easier to see an example how it all should work. And we'll find all of the missing pieces if there are any.
Okay.
One other
usually,
that, you know,
usually when we have SAI proposal, there is an example how the APIs are called, like common configuration example.
Okay, I can look at that. Yeah.
Sanjay, one other thought would be that, you know, in the attributes where you're defining the enums for different types of messages, you can split them into two, right? You know, like, you know, just have if you have 16 bits, you know, maybe higher bits are basically 8 bits. You can reserve it for standardized, you know, messages, and then maybe other bits be it for you know, saying that okay, you can either stuff or you can use for vendor extension attributes, right? That way, what happens is that at least you have some means of really defining it, and then that becomes really opaque for any implementation, so to speak.
Got it. Okay. I think, yeah. Okay. Yeah. I don't see in this, at least in the CPU control message for now, I didn't see any vendor specific this thing, but it will be a good thing to keep it that way. I think over time, we will realize there might be some vendor specific things that we want to do potentially. So that's a good idea. I think right now I didn't see anything vendor specific in the CP control, the last one that we are talking about. But when I look at making it into that enum, like Marian was suggesting, and putting it here, maybe in that we can make sure that there is extensibility towards what you're saying. Cool. That is this thing. So I think, yeah, I think I take two comments from here. One is, yeah, the enum thing. The second is sample code on how it calls. I think this needs some work in terms of probably making it more of a SAI compliant this thing, I guess. But yeah, the intent was to just draw a proper mental model on how it is working. The definitions I will look at making it documenting it in a more accurate fashion. Can we move to the next section? Yeah, I mean, if you look at each of the attributes and find something, I'm not having a nice process of getting feedback for each of the messages. Please do look at the messages on your own time and see if you see any gaps there or you see anything that glares out. Please do comment on that. Okay. So moving to the control plane message definition, again, like I was saying, this is the message definition that is that we are talking about here is here in the control plane channel, right? So this in this thing is defined as a bidirectional gRPC channel. So this is the gRPC channel we're talking about. So there's a bidirectional stream. And each of the stream carries the sync message. The sync message can be either a flow sync message or there is a control message, right? The control message is one of a DPU control message. What we have an equivalent that we were talking about there. It could be a compat check. There is a compat results message, and then there is a CP control message, right? So you'll find, I think, very similar equivalents in the SAI that we were talking about. So the compat check and the compat results were tied to the capability exchange, right? So there's the CP control message, which we were just talking a few minutes back. And then there's a DPU control message, which was the DPU to DPU control. Okay. So this is one of the control message is one of those. Right. So I think the DPU control message here, like we were talking, there is a type and then there is some data. So this thing could be, this is that vendor specific option here. Then there is the compat, this thing itself, the message that was there. The compat check has one piece, which is the VIP info. There is a VIP ID, which is the two VIPs that we have. There's an IP address, there is an admin role, and then there's a protocol metric. So sometimes when we need to control either the BGP and something like that we need to, there is a metric that is needed. So that is the protocol metric. And then there is a DPO info, which is the specific to this thing. So this mirrors what we saw in the SAI side, where there is a heartbeat interval and a miscount, which we saw in the DPU capabilities. And then there is the opaque capabilities themselves, right? This is the vendor specific capabilities we were talking about. Right? So there is a...
Hey, Sanjay, do you have a version number in the message that you exchanged to prepare for future extension?
You mean this is, I mean, you mean like a message version or a version of the software?
Message version, yeah.
Message version, yeah. So since this is protobuf, it's usually don't need that because it is extensible. But we
no, what I mean is, let's say you run an older version where you don't support this this extension of the new message, right? So what would be the behavior? So that's what the versioning is for. Versioning for the message itself, so that you know what information coming.
So usually, so one way that when you're defining on gRPC and protobuf, one way that this is handled is the protocol itself. Protobuf itself handles this versioning. So you could have two peers which are working off two different definitions of the message, right? So some of the invariants for, I think this is standard protobuf thing, which is the message ID doesn't change. So whenever we extend the protobuf on, whenever we want to make any extensions to the protobuf, there are some rules or guidance, this thing, right? So where the message ID doesn't change. And the protobuf itself will handle if there is if it does receive a message, which and it has a message ID in the which it does not understand, with the local definition does not understand, there is a way that the protobuf handles it, right, when it unmarshals it. So protobuf gives support for those kinds of extensions, right? But yeah, I think there will have to be care taken semantically to make sure that if the other side does not support, how do we communicate that, etc. In the sense to be able to handle when you get a message from an older version, for example, which does not is not specifying a parameter. So to have a reasonable default to be able to work with those things are things we can do. But specifying the header version kind of a thing, right? A message version is not strictly necessary with protobuf. If you see a necessity, I think you can see there is a specific need.
I feel the protobuf in general is a semantic, right? Whereas I'm asking more, I'm more concerned in the context of the actual HA handling between the two peer, whether they compatible, if they support all the message that's expected for the HA functionality itself. Yeah, not so much about the semantic.
I see. Okay. So that I was thinking we can be able to capture in the, we need, I think I misunderstood. So I think in the compat check itself, we need something else to say HA protocol version or something like that is what you meant?
Yes.
I see.
Yes. Another question I have is, you seem to have this both thing going through the Sonic depth. At what component in Sonic you seeing running the control channel protocol? Where are they in Sonic stack?
Yeah, so that I think we should the HA, the state machine itself. I think that is we need to decide which component will run the state machine. I think it would be somewhere where the state machine, the same component that the state machine is running for HA.
Yeah. So that one I think we probably want to implement this in the syncd process. Where it's I think the reasoning is being that first, this is a generic Sonic feature, right? So you need to be implemented in a Sonic, and then the second is that the syncd is directly linked with the SAI. So basically there's almost no overhead to get those flow info and then use it to transmit to the other side, right? So compare with the awk agent. So therefore, my thinking is that we can get it in the syncd container.
So in this case,
not
Guohan,
syncd, yeah. I mean syncd process.
Okay, so in this case, this will be a different thread than a new thread, Guohan, so that we're not impacting the programming of the DPU while the syncing is happening.
I think whether it's a new thread or other things, I think I think definitely open to that that approach. Yes.
Yeah, because this is a large amount of data that we're syncing across, right? So
yeah, understood.
Okay, thanks.
Oh, but by the way, I made a comment. Don't see if it's it. So right. So is it possible that we, usually a company with a, the side proposal, people will have a sample code to say, okay, how to invoke those side functions, right? So generally that will give people more idea how those API are used. And then people can walk through that code and think about, and that will be the basis for the, for the actual implementation. So I think that so it would be great if you add those sample code, how to call it, right? So I think if you look at other side proposal for some big proposal like this, they always have this sample code.
Got
you
it.
can look at.
We talked about that 5 minutes ago.
All right. Okay. Sorry, I missed that. Yeah.
It's okay. Yeah, that's fine. And they took a note to try and figure that out. And yeah. Go ahead, Sanjay. What were you going to say?
Yeah.
Also, one other thing, I wanted to mention about this packet IO, how a packet IO processing is done so far in Sonic also when we get the packet to the CPU. So here also we are essentially getting packets with the CPU, right? We are processing them, and it's going to be a channel, and then also we are literally getting things through gRPC, right? So we do have some implementation of the gRPC as well. So we have to see whether we want to really utilize that gRPC implementation that already exists in Sonic, and how does it really tie up with the stream channel that we are talking about here. But we also take a look into that one as well.
Mhm.
Which gRPC you are referring to?
Yeah, so Guohan, I mean, I'm talking about GNMI runs over gRPC, right? So
Oh,
yeah, so if we already have a GNMI, right? So and then GNMI has a gRPC. Do we want to duplicate it, or do we want to really, just have one implementation and then utilize that? I think those are the things that we need to really look at with respect to all the packet IO that we want to really process. Do we want to really do all the packet IO in the syncd, or do we want to have something? So all of those things are obviously some type of experimentation needs to be done in order to really realize that how it's going to scale, what are the other things that need to be done. And today the packet IO doesn't really come through syncd, right? It's a different way of actually going through any packet that comes to the CPU in Sonic.
sure. I
It's a
mean,
different channel.
yeah, maybe can you clarify the packet? Also, the fast pass is not going through the control plane at all, right? So what is the packet IO?
I'm
You are
talking about
referring?
all the control. I mean, today what happens is that, let's say BGP packets that are coming to CPU, right? They are not coming through, say, syncd.
Yeah, but
Isn't it
what
true?
is the packet you are referring to in this?
I'm talking about this flow pack, flow sync packets or control packets that are coming in. And then this was actually the discussion that, even Lisa was basically asking in terms of where
No, you mean
it's going to be,
the
right?
data plan sync or the control plan sync?
There is only basically this, flow sync and control plane messages, right? These are the two things that we are talking about here.
So
And this is a lot of data that there is a lot of data that we are
like
processing.
those sync packet, right? So my understanding that they are not going through the control plane at all, right? The DPU process and sent to the other side, right? So that's the data. Those packet doesn't go to the control plane at all. Are you referring to those packets or some other packets?
I'm talking about like bulk sync, right? Whenever you do the bulk sync, CPU is involved. Correct?
Yeah, but there's no package, right? So you just getting flow record, which is a 5 tuple from using the SAI API. There's no packets there, right? So.
But eventually they are aren't they encapsulated into something and then they're sent out to the other side?
Oh, that is a purely data plan functionality, right? So there were two parts. One is the bulk sync, and another one is I don't remember what is it called. It's like an incremental sync. Those incremental sync, those sync packet, I think, is being encapsulated and sent to the other side directly from the DPU. Those packets are not going through the control plane at all.
I see. Okay. Yeah. Depending upon whatever the rate at which it is, we just have to be careful in terms of how much we want to really expose it through the syncd versus how much we want to have some other means to handle it, right?
Yeah. So maybe this is related to the other question we raised. For example, like can we reuse the GMI, container and those kind of things. So I think that might be a little bit, as you noted, right? So the overhead might be a little bit. The path might be a little bit longer, right? Because it's a different container. You need some kind of inter process communication, so you can send those flow record to those GMI container, and then from there you go to the other side, and then get it back to the syncd, then to the side, right? So that part is a little bit long, right? So therefore, we, probably, it's better to shorten that path so that we can, directly, sync in between those two components, right? So therefore, we were thinking, just use a syncd because it basically link to the SAI library, and you can get all those messages from the SAI using native API calls, and then have a gRPC channel to sync it. That's probably the lowest overhead we can think of.
Yeah, clearly this may be the first place we can try, but just we keep in mind that what might basically entail, right? For any or the other things that are already other dynamics within Sonic that might be run into. But you're right. Actually, we can try the first thing to syncd and see how it performs, and then we try to see the reusability or scale or whatever be the case. We have to really we keep in mind about it.
Yeah, you're always the one who's mindful, Hanif, about the performance and overwhelming the hardware.
Yeah.
Hey guys, sorry I keep parachuting in and out. I had issues today.
Maybe this was discussed
Okay.
earlier. Is there acknowledgement in the process of bulk sync?
Is there? Yeah. There is no specific ACK unless you want the implementation needs something to say that, okay, we have processed this, I need to get to the other one. But there is an ACK, there is an acknowledgement at the end, which is the bulk sync done. There is a marker to complete the bulk sync, but there is no ACK per flow record or anything like that, if that's what you meant.
I meant overall for bulk sync.
Yeah, so there is in the state machine, if you see, there is a bulk sync done. There is an exchange that says that, okay, bulk sync is done. There is a marker at the end of the stream that says that this was the last flow record.
I see. And the acknowledgements for bulk sync, are they handled and processed in the DPU itself? Or are they?
Yes.
Sonic doesn't get involved?
When you say acknowledgements, did you mean, what did you mean by acknowledgements?
Bulk sync completion acknowledgement that the,
it passes through Sonic. It passes through Sonic. Sonic can handle it. But it needs to pass it back to the DPU too, because there is some state on the DPU that we will potentially need to change. For example, like we were talking in the last meeting, right? Once bulk sync is done, the way we are syncing the DP sync messages, right? For the flows that have been synced across already, there might be a marker we may need to put that the bulk sync is complete for this. So for that, we need to pass the message to the DPU too, but it passes through Sonic. Sonic also has visibility that bulk sync is done. So that was the compat message that we looked about. And then there is this, the equivalent to what we were talking about last time. I think this is what Marian was also bringing up. We need a enum. I think I didn't know the right way to put it inside. So I left it as a UN16. But here in this thing, like you see, it's a well-defined set of operations, right? This is the mirror image of, or not mirror, but the analog for what we saw in the side. Right? This is for controlling the state machine on either side. Other than this, there is the flow sync message itself. The flow sync message is a set, this is a batch of flow info messages, right? It's a batch. And each flow info has a key, and then the VIP ID which it belongs to, there is a key. And then the policy results themselves is carried in the metadata, right? So this is what we said, whatever the active had set up the policy results from the result, this thing, we pass it on to the standby. So we don't need to reevaluate everything. So that is the metadata. So I think as you might expect, the flow key has the 5 tuple, and I think the 5 tuple is defined here. Right. Other than the 5 tuple.
I know we had some preliminary HA APIs, I thought, in the repo. I'll try and find a spot where they were, so I can show them. I'll send them to you offline.
Okay. Right. So that is yeah. Okay, move on. So that was this thing. So we looked at the flow sync message itself. Then there is the control message. The different incarnations of the control message is what we saw. So I think since we are running about 6 minutes remaining, I'll just try to see if we can complete the different message flows, and then that way we can have gone through one round on this. So the message flows themselves, I think we can add more flows as we go. I think one flow that I have on my to-do list, which I've not added, is this preemption flow. I will do it soon and notify. But other than that, I think we have the node pairing and bulk sync. We have the unplanned switchover and a planned switchover. Okay. So the node pairing and bulk sync, I think these flow sync messages, I think, is to clarify how I think the state machine that we saw had a node-centric view. That was more of what's happening on one node, right, in terms of state. These ladder diagrams are these pictures. The message flow pictures are supposed to give the intent was to give a two-node view on how each of them are moving in relation to the other side, to the peer side. Right? In this picture, what was this thing is on the left side is one node. The right side is another node. In the left side is the node that was already booted up and existing, right? And it was in standalone primary mode state, and it is actively forwarding traffic. Right? At this point in time, the left node comes up. There is a peer connect. This is why on the heartbeat channel that we see a heartbeat, and there is a this thing. At that point in time, the sonic state machine, this I think from our discussion is syncd, wherever the state machine is running. There is the control plane channel, the gRPC channel gets established. And then once that gets established, there is this thing to notification back going to the SDK to register the CP channel that we saw in the SAI SDK. After this, there is a compatibility exchange, and there is a compatibility result that happens here, right? And then there is a notification from this is being pushed from when the newly coming up node is ready to accept this thing. So there's a start bulk sync message that is sent over the CP channel, and this is relayed to the implementation. And then you see that there are a bunch of these flow sync messages that are being exchanged, right, to sync the channel. Optionally, there could be messages, these Dpu control messages that are flowing in the reverse now, if you needed to do any of the flow control or anything like that. There could be these optional Dpu control messages that we talked about, right? And once this is done, the active side or the primary side of it, or the one that was already active, that knows that the bulk sync is complete, and then the bulk sync notification is passed back or relayed back through to all the way to the other side. One thing to note here is I think we have the black messages, all the black, the dark, this thing that is there. Those are messages that are happening on the CP channel. I also tried to represent the orange lines. So these lines are actually DP sync messages that are going on. I think it was just to illustrate that as we are doing the bulk sync, there will be DP sync messages also that are happening between the two nodes, between the two DPUs, right? So this will be for any new new connections that are getting formed or updates that are happening depending on what state. And I think we discussed this 2 weeks back and what is this thing. So this is the node pairing and bulk sync. Any questions here?
The heartbeat also has to be all the way end to end, just like the yellow line here, right?
Yeah. I haven't. Yeah, that's right. I haven't haven't tried to cover that in this picture, but you're right.
Well, if there's anyone with mad drawing skills who wants to help out, please do. Yeah. So we're 1 minute away. I'm Guohan, Prince, Marian, everyone. I'm not sure how you're looking on time, if you want to keep going or save this pairing for the next time. Anyone? Chris? Marian?
Yeah, I guess let's finish for today.
You wanna finish now and pick it up next time?
Yeah.
Okay. Thank you for taking us through this, Sanjay. It
Okay.
looks like we'll just need one more next week.
Yeah, okay.
And
Sure. I think
yeah,
that should be
and
short. I think we just have
yeah,
not much, maybe a couple
yeah.
of pages to cover.
That'd be great. And I ran the spell check on the document and got it fixed, got the words added, things like that. So
Okay.
I did that. And so great. If anyone wants to read it, throw a PR this way. Thank you very much. I'll stop the recording and share it like I always do. And guys, I'll have